In this problem, we're given 4 sets of data and we're asked which of the following sets of data represent valid functions. The definition of a function is that every input have exactly one output, meaning it can't have more than one. Let's look at this relation g. Is relation g a function? Look at the input -3. The fact that they have the point -3 comma -2, this says that if -3 is the input, -2 will be the output. So far it only has one output. This fits the definition of a function. If you look through the rest of the points, there's no other point in the set of data that has -3 as an input being sent to a different output other than -2. So far it's a function. But here, looking at point 2 and point 3, you can see that g is not a function. This point says that if you plug 1 in, you get out 3. This point says if 1 is the input, you get out 6. So if someone were to ask you what happens when you plug in 1, you'd have 2 different outputs as an answer. If you plug in 1, you get out 3 and you get out 6. So this would not be a function. For students that are confused with this explanation, what I do is I offer them what's called a vertical line test, because most students are better at the vertical line test than they are understanding this explanation. So to show why the vertical line test works, this is a perfect example. The reason this was not a function was because of the points 1, 3, and 1, 6. If I go over to this over here and graph 1, 6, let's see, this would be x equals 1, y equals 1, 2, 3, 4, 5, 6. You'd have a point about right there. The point 1, 3, if I graphed that, would be over 1, up 3. The vertical line test says if it's possible to draw a vertical line and hit more than one point, then something would not be a function. And the reason this works is that if you can draw a vertical line and hit more than one point, that means that these dots are stacked on top of one another. Well, if the dots are stacked on top of one another, what does that mean? It means there's an input here, namely 1, that got mapped to 2 different outputs, namely 3 and 6. So I'm not going to select this one. This is definitely not a function. Let's look at the relation S. The relation S has a point where it says that if you input -1, you get out -4. This point over here looks like it's going to give us some trouble because it also has an input of -1. But I need not be worried. It sends -1 to the same exact output as this one. So if someone were to ask me what is the output when you plug in -1, I'd only have one answer. The answer is that if you plug in -1, you simply get out -4 and no other. So this is still a function. Going through the rest of the points, this sends 2 to an output of 3. That's an input that only has one output. There's no other points that sends 2 to any other output but 3. And then the same thing with 6. 6 goes to 4. 12 goes to 15. This is an example of a function. If I was to go over here and plot the dots, I would never have any dots stacked on top of one another. You may think that -1, -4 written twice might make this not a function. But imagine plotting the dots. If I move over -1 and down to -4, I'd plot it. Later on, when I get to -1, -4 again, I would just notice it's a duplicated point. It would be the same point again. It would still not fail the vertical line test. I'm saying this is a function. Look at relation R. Relation R turns out that it's a function. If you look at the x values, they're all different, which means every x value is going to be sent to one y value. Every input has one output. So for example, if you plug in -4, you get out -1. There's no other point that's going to send -4 to a second output because there's no other point with -4 as an input. And that's the case for all of these points. This is the only point with an x value of 2. This is the only point with an x value of 6, 7, and 15, and so on. If you want to take the time to plot the dots and see that this is a function, you could do that. You could plot all 5 of these dots, and none of them would be stacked on top of one another like it was in the case up here where it failed the vertical line test. So I'm going to say the relation F is indeed a function. The last set of data, if you look at it, is the same as the set of data F. Relation R, I believe, is the same as relation F, that my x values never get repeated. Here I have an x value 0, then 1, 6, 8, and 10. That means every input's only going to get mapped to one single output.